Hello. First of all, I just really want to say thank you to everybody that watched my video last week. Thank you for all your feedback and your comments, all your messages on Instagram and stuff. I really appreciate it. So I've done another little video this week. I was so lucky. I had the opportunity to spend the day with David Savery. So you may have seen on my Instagram that I was with David last week. Not gonna lie, I had the best day. The man is a fountain of knowledge, and I took full advantage by asking him about 5 million questions. But yeah, we had a brilliant day. We had a whole day of like testing. So he was testing out this new TIS MFT Eco, and he's got his little test rig set up in his tech lab. So we had a little play with that. He put a fault on it, which was brilliant. And yeah, when I had to find it, it was really good. So David has made, I don't know how many videos it's going to be, but he's did a lot of recording. So there's going to be a lot of in-depth testing videos coming out, and fault finding. So yeah, keep an eye out for those. This video is just a really basic run through of the tests that we do. I get asked by apprentices and stuff to do videos on testing, so I just thought I'd take the opportunity while I was with David and I had that little test rig set up where everything was there, to do this video. So yeah, it's only short. I hope you enjoy it. Same again, any feedback, comments, anything, yeah, look forward to hearing from you. Enjoy.
With hints, tips and tradie chat. Grab yourself a brew because it's about to start. This is Women in Trades with Amy the Sparky.
Before the show starts, I just quickly wanted to talk to you about Tradify. Tradify is a fast-growing job management platform for all busy tradespeople. It's great for managing all sorts of business admin such as quotes, tracking invoices, timesheets and appointments, leaving you more time to focus on other important things. Tradify have very kindly given me a discount code for my viewers, so check them out by clicking the link in my show description and using discount code AMY50 to get 50% off. Now, let's crack on with this show.
Hello, Amy the Sparky here, and this man. I've been very lucky today. I've spent the day with David in Leamington doing a little bit of testing out, well, this new tester, the TIS MFT Eco. So yeah, I'm going to be showing a little bit of dead testing and live testing. So yeah, I'll show you a little run through now. So I have isolated the board. I've turned it off here. I've used my TIS 859 and a proving unit to test that it is actually dead, and it is. So I'm going to get testing. I'm going to test this ring circuit today, which feeds these two sockets. So there's a little bit of length, so it's more like a real scenario. There's about, I don't know, what did we say earlier, about 9-10 meters of cable, like wire in there. So just so we get some sort of figures.
This being a test setup, of course, this is not a live, well, not a real board in someone's house. This is our test rig to play on.
So first dead test is the end to ends on the ring. So we do R1, Rn and R2. So we take both of those out. Those and those. So I've already nulled the leads ready, and it's on continuity on here. So clips on both of the lines. Just give them a squeeze, make sure they're on properly. And then so we've got 0.08 on the line. So I'm expecting my neutral to be, well, exactly the same figure, to be fair, because It's the same size cable and the same route, so the same length. 0.07, close enough.
I can live with that.
Yeah. And then CPC.
And CPC on this circuit is a 1.5 mil.
Okay, so I was expecting my number to be a bit higher. So it's 1.67 times higher, because that's how much thinner, if that makes sense, smaller the CSA of the CPC is.
Absolutely.
Does that make sense?
If you divide 2.5 by 1.5, you get
1.67. So if you did 0.07 times 1.67, you'd get 0.11.
Yeah, somewhere between 0.11 and 0.12. So
Yeah.
that's all right. That
spot
works.
on, really.
Must be okay.
So that's good.
That's the ring end to end.
Ring end to end, yeah. R1, Rn, R2. So we're going to do R1 plus R2 now. So we need to connect one leg of the line to the opposite leg of the CPC. So David's already marked these cables because this is test setup. So I know that this one is the opposite to this one. Okay.
Lovely.
And then I plug this into here, and I'm expecting the figures at these two to be very close. So 0.05. And this one 0.05. That's good.
Hey.
That's what I want.
If you wanted to prove it mathematically, and you could be the type-winner of the calculator, we could take the R1 figure we got earlier, which was 0.07, was it?
0.8, wasn't it? 0.08.
Was it 8?
It's 8 on one and 7 on.
All right, well,
8 on neutral line.
Okay, go for 0.08.
Should we argue about it? That's not a good argument, are we?
I don't think it's going to matter that much. So 0.08 for the line, and add it to the value for the CPC, the R2 number, which is 0.11,
Yeah.
I think. And because we've got 4 conductors, 2 lines and 2 neutrals, divide that number by 4. And we get
0.475. And I tested out at 0.05, so
yeah.
I'm happy with that.
So the calculated result matches what was measured, which means that ought to be all right. And we should see that result, of course, at all our ring sockets, except for any spurs, which may have a higher value.
Why would they have a higher value?
Because you would have an extra cable sprouting off one of them, going off to another destination somewhere, and you'd have to take into account the resistance of that extra cable.
Well done, David. Excellent answer. It's like you know what you're doing.
But I got that right. I got that right.
The next test is insulation resistance. I've set up the tester to 500 volts.
What's the pass limit on this test, on that tester?
It's 1 megawatt.
Yeah. Super, because that's the minimum prescribed IBS 7671, isn't it?
First I'm going to test between, first of all, sorry, I've connected my CPCs back into the main earth bar. That's just so that when I'm testing between the live conductors, I'm testing the whole earth installation rather than just those CPCs, like that circuit. So I'm going to test first between line and neutral. I don't need to connect both of them in because I know that they're connected from doing my end-to-end tests.
Yeah, as long as you've got one wire there. We should be safe line to neutral here as well, shouldn't we? Because it only serves 2 outlets.
Yeah, I know that. I know there's only these on the circuit and there's nothing plugged in, so I know that it's going to be safe with 500 volts.
What can go wrong?
So this is showing that the test took 3 seconds. It sent 523 volts down the circuit, and it was off the scale. It was the highest resistance it could.
Yeah, over the highest resistance it could
over this meter can measure. So then I'll go line to earth. Same again. Exactly the same result, perfect. And I'll go neutral to earth. Exactly the same result. Perfect! Thanks for that. I love a closer. Oh, I love that. Thank you. So yeah, that's as good as it gets. That's what I wanted.
I believe that's the end of the dead tests.
Yeah, that's all the dead tests. If you've got any questions on dead tests, or this TIS MFT Eco test meter, you can message me, or well, you can message me about this because I'm going to be playing with it quite a lot. Any questions about testing, you can message David because he's taught me. He knows a lot more than me. Or you can message me, that's fine, because then I'll just message David. But yeah, that's dead testing. Easy as that. Okay, so I'm going to be doing some live tests now. So first of all, I've got my external impedance test. So I've set my machine up here to test between live and earth. I've switched it on here, but my board is switched off, so only my incoming is live. I've disconnected my main earth from the main earth bar. That's just so that my result is not affected by any other earth, so like bonding or anything. So I'm literally just testing my main earth cable. So I clip onto here. This one in the live, and there we go. Okay, so 0.32, that's fine, because the maximum, this is a set up as a TNCS system, and the maximum it's allowed is 0.35, so that's within range. And then the fault current showing us 718 amps, or 0.718 kiloamps it'd be, wouldn't it? That's fine, the figures are acceptable.
I suppose the only thing to say is that if your impedance is lower, your fault current will be higher, because they work, they're inversely proportional to each other.
Yeah.
So a lower impedance means a higher prospective fault current, and you just want to make sure any breaking capacities of devices are within the fault current range that you're reading.
Which these are, so
easily.
Happy. Next test is the ZS test. So it's a live test, so I've put the board cover back on. I've set up the test meter. So this meter does a 2-wire no trip test. That's just a function of this tester. So I took my socket front off, and I only need to test between earth and line. So they're on, and then yeah. So hopefully the RCD shouldn't trip.
I think normally as well we do these sort of tests from the front of the socket outlet, but just to show off that this is a true 2-wire test without causing the RCD any trouble, we'll do it from the rear. It's best to do it from the front, just because that will highlight a socket with a dodgy output, something that's a bit dirty or greasy or not quite right.
So we've got a result of 0.44, and the RCD didn't trip, so the 2-wire test did work. I'd calculated the figure to be around 0.37. That's by adding my R1, R2 and my ZE, so it's close enough. It's not exactly spot on. It could be these connections, could be the way I was holding it. It might not have been quite tight on, but
yeah, you've really got to shove them in there, haven't you, to get a good contact, but it's not too far off, is it?
Okay, so we're going to test the RCD now. So I've set up my meter. It's on auto, so it's going to test through 1 times, 5 times and half times, and it will test at 0 degrees and 180 degrees, just one after another. So I just need to press go. Oh, so I've plugged it in here, so ready. My glamorous assistant. Resetting.
No glamour was involved in the making of this video.
So we're looking for this to not trip now. Perfect. And perfect. So it's saying it's okay, which it is, because 1 times needs to be less than 300, and 5 times needs to be less than 40. So yeah, so they're well within.
Super. Also with this tester, you have different types of RCD. We're testing a type AC here because that's what that is. But we'll be testing this device. We'd have to switch it to the type AC function.
Let's do a ramp test as well. So it's on auto now. We go to here.
Yep.
We've reset the RCD.
And we should see tripping at what sort of point?
Between 16 and 30 will be a pass. So that's at 24, so that's fine.
Marvellous.
All good. It's all good. If you want to see that, but in a lot more depth, watch David's video or series that we've recorded today, which is
It might be some time before that gets edited.
It might be a little while, but it is coming out. It was really interesting. We did all the different tests in quite a lot of depth. We talked about different calculations and results that we're looking for. We also had a fault on this circuit that we found, and it was really interesting, like actually genuinely interesting. I haven't been bored all day, honestly. No, I haven't. It was really, really good. So yeah, when David gets around to sorting his video out, give that a watch, and yeah, leave us some feedback about my beautiful new tester. Okay, thanks. Bye. Thank you so much for watching my video. I really appreciate it. As you may have guessed, at the end of the day, David so kindly gave me that tester. So now I have my very own tester and I can stop borrowing one. Check out David's videos. They're absolutely brilliant. Any questions on testing, send them to David or me, and I'll send them to David. Have a great week, and because this is coming out on Friday. Bye.
That was Women in Trades with Amy the Sparky. Never miss an episode by subscribing now. Just hit the subscribe button and turn your notifications on.